In this lesson, we're going to learn how to translate coordinate points. If you're following along in your notes, please write this down with the appropriate page number. All right, let's get started. In today's lesson, you're going to be able to perform a translation by using an indicated notation to rename an ordered pair. You need to know these three things: that a translation is a shifting of a point or several points left, right, up, and down. There's no flipping, there's no turning, and there's no changing size. We're going to be talking about two types of notations today: mapping notation and letter notation. All right, let's review what we covered in our previous lesson. A translation is a slide or a movement of a figure to a new position without turning, flipping, or changing size. A translation can move left or right or up and down. It cannot move diagonally. What we see here is actually a combination of two moves: a move to the right and a move down. Let's take a look at these 9 shapes. The question is, if the red figure is translated to the blue figure, is the red figure a translation towards the blue figure? Remember, a translation is a sliding left, right, up, or down. It is not a flipping, it is not a turning, and it's not a changing in size. Why don't you give these 9 a try? Pause the video now. All right, let's see how you did. Notice with number 1 that the size of the red backward C is much smaller than the size of the blue backward C. So that is not a translation. For number 2, if I have a red triangle and I slide it to this blue triangle, right, they still remain the same shape and size. All right, let's get into the actual math. I have a coordinate drawn on this set of axes. We're going to be taking our coordinates and sliding them, sometimes to the left, sometimes to the right. Notice when I slide them, I always stay on the same horizontal line, no matter which way I go. A shift to the left or right only moves along the x-axis. So 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2. I'm talking about the coordinates. Notice that the 2 always remains the same. That's because the 2 is a y coordinate. And when I move left or right, I do not change, I do not change the y value. When I move left or right, I'm changing only my x value. Now if I move up or down, I follow along the y-axis. 3, 2, 4, 3, 4, 3, 7, 3, 9, 3, 0, 3, -3, 3, -5, 3, -8. That x coordinate always stays the same. This one, 3, 2, 3, -7. So I want you to pay attention today to which coordinate changes and when it changes. All right. We just saw by the motions that I did on the coordinate graph that when you move left or right, you change your x coordinate value. So you notice here I have a combination sign. I have a plus sign and a minus sign. Sorry. I have a plus sign and a minus sign. And that's because you can move to the right or you can move to the left. If you are moving to the right, you're getting larger. If you're moving to the left, you're getting smaller. So be careful when choosing whether to add or subtract. Left is subtract, right is add. The same goes with the up or down coordinate. When you move up or down, you move along the y-axis. Therefore, you change the y-coordinate. Sometimes you add, sometimes you subtract. Up is adding, down is subtracting. When you write your translation as a math sentence instead of an English sentence, it's going to look like this. When you write the translation rule in this format, it's called a mapping. All right, let's try an example. Let's translate the coordinate 9, 5, 4 units left and 6 units up. This is written in English. So if we want to write it in math using mapping notation, we're going to talk about whether we're going to add or subtract those numbers. 4 units to the left means you're going to subtract 4. 6 units up means you're going to add 6. So take your original point, 9, 5, and let's perform these mathematical operations. Subtract 4, add 6. Oops, sorry. And there we have our new pair. Let's try another one. Let's translate the point -2, 5, 2 units to the left and 1 unit up. Remember, left is subtracting and up is adding. So -2 to the x value and +1 to the y. Now you can do this in your head, or you can even write it underneath. My new ordered pair is -4, 6. Let's try another one. Translate the point 4, 8, 3 units right and 2 units down. Remember, right is getting larger, down is getting smaller. 3 units right means you add 3. 2 units down means you subtract 2. And that's all you need to do. One more time. Translate -5, -3, 2 units left, 1 unit up. As soon as your brain can figure out those operations, the rest is pretty easy math. Minus for the 2, plus for the 1. Now for some of you, you may want to use a calculator to do that math. All right, one last time. 2 units to the right, 6 units up. Taking those notes might help you. That wasn't so bad. I think you're ready to try these 3 on your own. Pause the video now. Okay, let's see how you did. The original points are in black, and the new points are in green. Hopefully you got them right. Alright, instead of telling you in English, I'm going to tell you the translation in math this time. So all you need to do is perform the mathematical operation that you see here. But then I ask you to describe it, just to make sure you know what it means. So again, the first thing you do is perform the mathematical operation. Subtract 2 from the x-coordinate, add 9 to the y-coordinate. Once you have that done, process the information about how you're moving. Minus 2 is either left or right. Since it's a minus, you're going to the left. And the y-coordinate is always up or down. Positive 9, that's an up move. Calculate your math, and you're all set. Let's try that again. Perform the indicated transformation and then describe it. Again, add the 4 and the 2 to your ordered pairs. Then process the information about which direction you're moving. X is always left or right, Y is always up or down. Use the signs to help you. Positive 4 is right, positive 2 is up. And there's your new ordered pair. Let's try it again. Perform the math. Describe the movement. Getting the hang of it now? Alright, try these 3 on your own. Pause the video now. Okay, you ready to check your work? Let's see how you did. Great job. Alright, another way to describe a translation is to use this different notation. It's a letter notation. The capital T stands for translate. And the numbers down there stand for how you're going to change your coordinates. They're in the same order as your ordered pair. So this one would minus 2 to the x value, and this would add 5 to the y value. Again, this is left or right, this is up or down. So this one here is left 2, and this one here is up 5. Let's perform that transformation on the ordered pair 5, 2. Simply take these values and write the math underneath or do it in your head. Minus 2, positive 5. That's it. Let's do it again. Perform the indicated transformation. Remember, that stands for translation, not rotation, not reflection, right? T for translation. Positive 4 to the right, negative 8 down. The new point is 5, negative 10. Getting the hang of it? Let's try it one last time. Pretty simple math. I think you're ready to try these 3 on your own. Pause the video now. Okay, let's check your work, see how you did. Great job. Alright. So I know that we can see that this is a translation. Do you know which shape is the original figure and which shape is the new image? You can tell by looking at the letters. The letters with the prime signs are the new image. So the black image is the original, and the red image is the new one. To get from G to G prime, I moved 1 unit to the left. Do you remember which coordinate that affects? 1 unit to the left changes the x value. So the notation I would use here is this. If you want to use letter notation, you would write it like that. Let's try another one. Remember, triangle ETI is the original, and E prime, T prime, I prime is the new figure. Now remember, you can't translate diagonally. So we need to count left and right, or up and down. So let's go left or right first. We'll start at our original, and we'll travel 1 unit to the right. Remember, right is adding. Now let's write the effect on our y-coordinate. 2 units down. And that's how you write the translation. You could also write it like that. Alright, let's try 2 more. Now, this shape has a lot of vertices, but they all move the same way, so you just need to count one of them. I'm going to go over here and count the translation from u to u prime. It looks like I'm just moving up. 1, 2, 3, 4. Up does not change the x-coordinate. You could also write it like this. Alright, let's try the next one. I'm going to start at D and travel to D prime. 1, 2, 3 units to the right. 1, 2, 3 units down. You could also write it like this. I think you're getting the hang of it. Why don't you try these 2 on your own? Pause the video now. How did you do? Did you use mapping notation or letter notation? Either one is right. Alright, you learned how to transform a coordinate by simply changing the ordered pair. And that's the end of this lesson.